Hello everybody, welcome back to my channel, and today we'll be seeing how to find the middle of a linked list. So we'll be using two concepts. One is finding the middle of the linked list like in the normal method, and also we'll be using the other method to find the middle of the linked list, which is by using the concept of slow pointers and fast pointers. So we'll be covering both of them in this video. So let's start with the normal method first. So for example, this is the linked list and we have to find the middle of this linked list, and now the middle of this linked list is, as you can see, is this one. So the only question is, like, the only target of this question is that we have to find the address of this, which is like 400. But what if we have like a even number of elements? So if I just see, if we have like 1 2 3 4 5 and we have like 6. So now you would say, like, what is the middle of this? Because the middle of this could be even this and like this. So basically this is the entire middle, but how do we find the middle of it? So in this case the middle will be, this will be the middle. So yeah, so firstly we'll be just iterating through the entire linked list, and we'll be finding the count, like we'll be finding the size of a linked list basically. So initially I'm taking count as 0, and then I have taken temp, which is a pointer, which is of the type list node. It can be also as a list node or a node, you can put it as anything. And initially I'm putting the temp to be at the head, so the temp is right over here. So initially the head is here, which you can see, and then while the temp keeps on going forward, it keeps on going forward, it keeps on going forward until the temp is not equal to null. Until the temp is not equal to run, the count will be keep on be increasing. So when the temp is over here, the count is 0. When the temp goes over here, the count becomes like 1, then it becomes 2, then it becomes 3. So it keeps on get increasing. The temp keeps on being going, and until the last condition where temp is over here and the temp of its next is what? It's null. So here there is like null things over here. So till here the condition keeps on being going and the count keeps on increasing. So by the time this while loop gets over, the count value, till like, by the time this while got over, the count value became 5, and here the count got divided and it became, which is basically 2.5, which becomes 2. So the second position becomes the mid. So now again the temp value is being resetted to head. So this temp which has reached till the end, now it is resetted to the beginning. So now again the temp goes back to the first position, and till the count becomes 0. Like, this basically means until count becomes 0. And here, by the way, this is the new count. So until this 2 becomes 0, keep on printing, like keep on going temp of next. Finally your temp will be in this middlemost position at last, finally. And you can just you can just return the value of temp, and this way, this is like the normal way of finding the middle of a linked list. So let's just go to leetcode.com and do it the normal way. So here is the question: we have to find the middle of a linked list. So middle over here is 3, the middle over here is 4. So like, how do we do it? So let's just go over here. So first we'll be creating a temp, which is a pointer of type list node, or it's just a pointer of type node. So list node star temp is created, and temp is equal to the head for now, because like we have to iterate it, so we are going to start it from the head all the way till the end. And also I'll just point in count is equal to 0. So while my temp is not equal to null, like until the temp doesn't reach to the last most position, like it reaches to the end where nothing is there, where null is there. Until then I will just keep on increasing the value of count, and the address, I mean, and the position of temp also keeps on shifting from one node to the other. So even temp's next address has to be changed. Temp next, and put a semicolon over here, and that's pretty much it, I guess. And by now the entire LL is iterated, and yeah. So now we find the half of the count is equal to count by 2, and now we are gonna, now also one more thing you have to do is like reset, no, so now we'll just print it. So while count exists, while count exists, I will just put temp is equal to temp of next, and yeah, like while count exists, count of minus minus, temp is equal to temp of next. And also one more thing you have to do is, which you have to reset the position of temp, because in this iteration, like specifically over here, the temp kept on going forward, so the pointer is now reached at the final position. So we'll just reset it again to the initial position, temp is equal to head, and now we'll print it. It will get printed only till the half position, and now we'll just return the position of temp, which will give us the address of this middlemost element. And I'll just put a semicolon over here also, because after every while put a semicolon. Now let's just run and see. Our both of the test cases are passed, and yeah, that's pretty much it. And also in the question which they have told, like if there are like two middle linked lists, and if there are two middles, so return the position of the rightmost one. So like return the position of the second middle node, and let's just submit and see if it gets submitted. It got submitted. So this was the way of doing it in the normal method. And now let's use the concept of slow and fast pointers. So before we study even the concept of slow and fast pointers, let's just see a thing. Suppose there's a like an entire track over here, and you have to find the distance. Suppose there is only one guy in the entire track, and this one guy goes with the speed of 10 kilometers per hour, and you have to find, you don't know the entire distance of the track, but you are told to find the entire distance. So what you'll do, he keeps on going all the way till, so it takes 10 hours, so it covers 10 kilometers per hour, and it's 100 kilometers, so it takes 10 hours. So it goes 10 hours all the way till the end, and it realizes, okay, I have reached the end now. Now it has to find the middle, so it will go 50 kilometers backwards, so it will be covering like 150 kilometers. So this is not, it takes a lot of time. So we can make it a bit faster by using the concept of slow and fast pointers. So what will happen is that, and also the condition of this entire question is that this guy has to find the entire distance and also come back to the middlemost position. So how much time will it take? So it will take like 10 hours to go over here, and then it will take 5 hours to come over here, so like 15 hours it will take. So how do we make this thing faster? So we can use the concept of fast pointer, slow and fast. So this guy is faster, so he runs at a faster speed. So this guy will reach over here like within 5 hours. So just put it properly. So this guy will reach over here like within 5 hours, and the moment he reaches over here, he will say, hey, total distance is equal to 100. So he'll just tell this guy to, okay, you just come all the way to the 50th position, and our main goal was to bring this guy all the way till here, which was the middle. So this is the concept of like slow and fast pointers. So how do we find the middle of it? So how do we put this slow and fast pointers in the linked list? So how do we do that? So the thing is, So the slow keeps on going one node after the other. So the slow is here, then it goes over 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 here. So the slow keeps on going one node after the other, like normally it keeps on going. But whereas, so the fast skips this one, goes over here, then it skips this one and it goes over here. So it has skipped, it keeps skipping one node after the other. So how do we find the position where, like how do we find the condition where finally the fast pointer has to end? Two conditions. So the first condition is where when the fast itself is at the null position. So if fast is equal to the null, then just stop. And if the next address of fast, like after this fast over here, what is there? Nothing is there, like null is there. So if even the next address of the fast is null, then also stop. So these are the two conditions for fast to get stopped. So now let's just see the code. So I have made two pointers which is of the type list node, and both of the pointers initially are at the head position, which you can see. So now initially both of them are at the head. So now I'm going to use these two conditions. So until fast is equal to null, like until like fast completely reaches over here, or the next position of fast is also null, or and basically until it is at over here and also the next, then keep on moving the position of slow to the next position and keep on moving fast to next of next. So it becomes fast of next and also of next. So it becomes fast of next, and finally by the time fast reaches to this pit where nothing is there and null is there, or it reaches over here, the slow guy would have been reached to the middle, and we'll just return the position of slow. So now let's just go to leetcode.com and try solving this question. So now I'll be using two pointers which is of type list node. So list node star slow, which is at the head position, and list node star fast, which is also at the head position initially. So while head is not equal to null, and while fast is not equal to end null, and fast of next is not equal to null, you just push the like slow is equal to slow of next, and fast is equal to fast of next again, and we just put a semicolon, always put a semicolon after your while ends, and now we return the position of slow, and I guess the load code looks fine, so let's just run again and see. Yes, our both the test cases are passed, and if we just submit, it will get submitted again. It got submitted, and yeah, this way we have found the middle of a linked list, and we have covered both the concepts of the normal way and also using the slow and fast pointer. So thank you so much for watching the video. Until next time, goodbye. I love you all.